Welcome to today's GFG problem. Today we're doing well. So let's say today's problem: count all triplets with given sum in sorted array. Okay. So what the problem is saying is we'll be given a sorted array and we'll be given a target. And what we want to do is we want to we want to find out the count of all the triplets whose sum is equal to the given target. Okay, whose sum is equal to the given target. Okay. So let's see in this example what are those triplets, right? So one of the triplet is minus 3, minus 1, and minus 3, minus 1 and 2, right? Minus 3, minus 1, 2. If we add them, it will be minus 2, right? It will be minus 2. Again, another triplet is minus 3, this particular minus 1 and 2 again. Minus 3, minus 1 and 2 again, which will provide minus 2. Another triplet is minus 1 and 0, right? Minus 1 and 0. Okay. Another triplet is minus 3, 1 and 0. Minus 3, plus 0 plus 1, which will give us minus 2 again. Okay, so there are overall 4 triplets whose sum is equal to the given target. Okay, you have to return the count of those triplets. I hope you have got the problem. Now let's quickly see the naive approach first. So what will be the naive approach? So we can solve this problem using 3 for loops. Okay, so how it will look like for I equal to 0 to n minus 2. First for loop will go up till n minus 2. Then j equal to I plus 1. It will be j equal to I plus 1 to n minus 1. Okay, and third follow will be k equal to j plus 1 to n. Okay, to n. Okay, so using this 3 follows, you'll be able to solve this problem. We'll take a count variable. Okay, this is to keep track of the triplets, and we'll take sum equal to arr of I plus sum equal to arr of j plus sum equal to arr of k. Okay, and we'll compare this sum with the target. If it is equal, we'll increment the count. Okay, this will solve your problem, but the time complexity it is going to take is O of n cube, which will be because there are 3 follows. Okay, okay, okay. So we need to see now. We now need to see whether we have better approach than this. Okay. So let's see. Definitely we have a better approach. Okay. So let's see how we can solve this problem using time complexity lesser than O of n cube. My bad. Let me see what is happening here. Okay. Yeah. Okay. Now what we'll do is let me rewrite it again. So we are going to use the pointer technique. Okay, the pointer technique. So what are we going to do? Minus 3, minus 1. Let me rewrite this example again. Okay. So we are going to run a for loop. Okay. That and the index it is going to be okay. It is going to be I. Okay. We'll have this for loop and we'll have 2 pointers L. L will always start from the next element of I. From the next okay, L will always start from L equal to I plus 1 and R will start from the last which is n minus 1. Okay, last which is n. Let me write the okay, let me write the code. Okay, let me write the code, you'll understand better. In n equal to, let's quickly say n dot length, right? Then let's have a this for loop, right? I equal to 0, I will go till n minus 2 till the third last element. Okay, I plus plus, and we'll have L as I said, it will always start from I plus 1 and R will have which will be will be the last element. Okay, we'll be bounding at the last element. We'll have a while loop L less than R, and then we are going to have some R of I plus R of L plus R of R. Okay. Now what we're going to check here is first of all, if sum is less than target. Okay, that means we want to increment our left pointer. Okay, we want to increment the left pointer because incrementing the left pointer will give us a bigger sum. Okay, bigger sum. Okay, else if sum is greater than target, okay, we want to reduce our sum. So we want a smaller element, right? We want a smaller element. So we will reduce our right pointer. Okay, we'll decrement our right pointer. Now, if the sum is equal to target, right? The sum if it is equal to target, that means now let's see now what we need to do here is okay. Now we'll see here. Okay. Now for example, now let's see since we have sum, right? Sum equal to what we did r of I plus r of L plus r of R we did, right? We did this. R of I is what? Minus 3 plus r of L is minus 1 plus r of R is 2, right? So minus 3 minus 1 plus 2, which will give us 4. Which will give us minus 2. Will give us minus 2. Now this sum is equal to the given target. And hence this condition will be executed. Else if this condition will be executed. So just be with me. I'll also show the C++ code post this code. Okay. So yeah. So now what we need to do here is, now let's see, we'll see here. Okay, let me rewrite this example again. Minus 3 minus 1 minus 1 0 1 and 2, right? This is a current state, okay, wherein we have L, we have R. Okay, now what we're going to do is, we have found one triplet, right? We have found one triplet. Okay, minus 3, and what is that triplet? I is here, minus 3, L and R. This is the triplet, right? Now, for the duplicate elements, for example, the elements after L, for example, here, the duplicate elements are this and this, right? Another example, we'll see here, right? This is also we had included. Had I shown this example up? Okay, so let's consider this as example. This is example, okay? We have additional 2 here. Okay, before this 2, we have additional 2. Okay, now the current state is this. We have I, L, and R. Now for the duplicate elements, for example, minus 1. Okay, minus 1 and 1. Minus 1 and minus 1. These are the duplicate elements, right? So we have found, first of all, we have found one triplet, which is this one. Minus 3, minus 1, and 2. Okay. But if you look, we have duplicate element. So this can also be one triplet. Minus 3, this minus 1, and this 2. Right? Minus 3, this minus 1, and this 2. So for such elements, for such duplicate elements, okay, we will already have a triplet, for example. So for such duplicate elements, we'll do the processing this way. Okay, so let me write here. What we're going to do is, we are going to have two variables. One is count 1 and count 2. Okay, so why two variables? Why two counts? So count 1 represents the the triplet count for the elements pointing at the left position. You'll get what I'm trying to say. And count 2 is the triplet. Consider the elements at the right position. Consider the duplicate elements at the right position. Okay. Now we'll see what we're going to do here. So let me write. So here I'll implement the code. So we have found a triplet. Okay. We have found a triplet. Now what we're going to do is, we are going to have two variables, count 1 and count 2. I've already told count 1 represents the triplet considering the left position, and count 2 is the triplet considering the right position. Now we are going to have two variables. Okay, two variables wherein element 1 will represent the current element at the left index, and element 2 the current element at the right index. Okay, and what we're going to do here is, we'll have a while loop which will run till L is less than equal to R, and LE1 equal to R of L. Okay. Now first of all, now our sum was equal to target, and also this condition is matching. L is less than definitely equal to R, and element and R of L, they both are same. What is element here? Element is, for example, if you consider this, right, LE1 is this particular element, right, minus 1. And R of L, currently L is pointing here, so R of L is also minus 1. So this is matching. This is matching. So what I want to do here, since we have found one, anyways, we have found one triplet, we will increment a count 1, which is the triplet, which is a triplet count, right? Okay, triplet count, and also we'll increment our L. Okay, we'll keep on incrementing our L till we find the duplicate element on the left side. So for example, here, right? Now we have, what we did is, we incremented our count, right? And then we have also incremented our left position. Okay, left is now pointing here. Okay, now since LE1, which was the initial element at the left position, is minus 1, and this is also minus 1 now. So again, there's a match. So we can say there's a triplet. So what is a triplet? Earlier the triplet was minus 3, minus 1, and 2. Now the triplet is minus 3, this minus 1, and the same 2, right? And the same 2. Okay. So we will have R, will increment our count again, and will increment our L again. We'll do this until we find till we find the same element, till we find the duplicate element. This was for the left position. Similarly, we'll write for the right position as well. L is less than equal to R and LE2. LE2 equal to R of R, right? So in this case, we are going to increment our count to this you can consider anything. Okay, it's a post increment or pre increment anything. Let's be consistent. L plus plus and R minus minus here we need to do, right? R minus minus. So what we are saying is we have found the duplicate element. Okay, we have found the duplicate element. So we will increment our triplet count. Okay, and we'll decrement our R as well. So we'll do this till there are duplicate elements. So if we find how many, like if you find three duplicate elements, then we are going to increment this because there'll be again triplet, we can say. So here in this case. So now let's see. So where is the pointer? So currently, again, let me write the example again. -3, -1, 0, 1, 2, and 2. So currently our R is here. Our L is now here. Okay, L is here. L was done. I mean, we kept on incrementing, right? Until element 1 was not matching R of L. And our I is here. Okay. Now we are considering this right case. Okay, right case. So for example, we had already found the triplet. Okay, we had already found the triplet LE2. LE2. We'll have LE2 here. LE2 was what? R of R. Initial the right element at the right position, which is 2. Right? Now we're going to keep on comparing for the duplicate elements. For example, for the first time, LE2 is equal to R of R. So we are going to increment our count to variable and we'll decrement our R. Okay, we'll decrement our R. Again, we found the same element, right? LE2, which matches to the LE2. We found a duplicate element. So we have found a triplet again. What is a triplet? -3, -1, and this particular 2. Initially, it was -3, -1, and this particular 2. Now here it is -3, -1, and this particular 2. Okay. Okay. So yeah. So let me. So this is that particular while loop, right? Count to and are decremented. Okay. And finally, what we're going to do? We are going to have one result variable int r result equal to 0. Okay, result equal to 0. And here, what we're going to do? Result plus equal to CNT1 into CNT2. I'll explain this why we're doing count 1 into count 2. For example, um, let's consider this example again. So initially, what were the counts, right? -3, -1, -1, 0, 1, and 2, right? So initially I was here, L was here, and R was here. So there was this triplet, right? -3, -1, and this particular 2. Then another one was -3, -1, and this particular 2 again, right? -3, -1, and this particular 2. And hence, that is where the count one value was 2, right? Count one value was 2 because because of these two triplets, -3, -1, and 2, and again -3, this particular -1, and this particular 2. Okay, that is why count one value was 2. Now count 2 value is 2 again because of this particular -1, -3, -1, this particular 2, right? This particular 2, and -3, -1, and this particular 2. That is why this count 2 is 2. Count 2 is 2. And finally, since we have how many? We have how many triplets? 4 triplets, right? -3, -1, and 2, -3, -1, and 2. These are two triplets. Second triplet is third triplet is -3, -1, and this particular 2, and -3, -1, and this particular 2, right? That is what there are 4 triplets, and count 1 into count 2, right? Which is 2 into 2, which is 4. I hope you're getting my point. Okay, I hope you're getting my point. Okay, and that's it. What we're going to do here is we're finally going to return the result. Return result. Now we have to handle one more case. I think this should run for the base case. Let me compile this. Let's quickly check. Okay, it is matching. Now we have to handle one more special case, which will be, for example, let me dry run that 0, 0, 0, 0. This is the array, and the target is 0. Okay, so what are going to do here? I will be here, L will be here, and R will be here initially, right? Initially, Okay, it is going to be this. Now what will be the sum? Sum equal to air of I plus air of L plus air of R, which will be 0 and which will match the target, which will match the target, right? Right, which will match the target. Now what are we going to do? So considering this, let me uh, copy this, or let me take a snapshot of this particular case, right? We'll dry run this. Let me make it small. Okay. Now let's dry run this code. Okay. Now since we have found our a triplet, right, which is this and this, right? This is a triplet. This is a triplet. Now what we're going to do is consider this case, right? For the duplicate elements, first of all, this count one was 0. So with this triplet, LE and let's have element 1 as well. LE1 is air of L, which is 0 initially, right? Which is 0. Now what we do in this, we compare our air of L with LE1, which is 0, which is matches, and hence we're going to increment our count. We'll also increment our L pointer, right? We'll also increment our L pointer. Now again, LE1 and this is matching. So we can say we have again got a triplet. So we're going to increment our count 2. Okay. Again, we're going to increment our L. This while loop runs till L is less than equal to R. L is less than equal to R. Okay. Now this condition is still matching. Again, LE1 is also matching with air of L. So we're going to increment our L, this count 1, and also we'll increment our L. Now this condition will fail because L is greater than R now, right? So we have count 1 which is having 3. Okay, which is having 3. Now this other while loop, right? The second while loop, it is not going to be executed because L is exceeded R. Because L exceeded R in this particular while loop. Now this while loop won't be executed. And hence what we want to do is we want to check if LE1 equal to LE2. That means all the elements are same, right? If LE1 is equal to LE2, this will come in else part. Okay. The special case will come in this particular part, wherein element 1 and element 2 both are matching. For example, what was element 1? Initially, element 1 was this, and element 2 is this, right? Element 2 is this, which is the air of R. Okay. So both are matching. So this is a special case. In this case, what are we going to do? Result plus equal to CNT1 into, this is a special case, into CNT1 minus 1, okay, divided by 2, divided by 2. Okay, so now you can check, for example, how many triplets will be there for this particular case. 0 0 0 0, there will be 3 into count 1 into count minus 1, which is count minus 1, 3 minus 1 divided by 2, right? 3 into 2 divided by 2, which will give us 3 triplets. There will be 3 triplets. Okay, there will be overall 3 triplets. How 3 triplets? 0 0. For example, let's consider, let me write here 0 0 0 0. This was that, right? So one triplet is what? This and this. One triplet is this and this. Second triplet is this and, sorry, my bad. Second triplet is this and this, right? Second triplet is this and this. Third triplet is this and this. So these are the 3 triplets, right? These are the 3 triplets. Okay. So count 1, okay, divided by 2. So this will give us the special case. This we are handling the special case. Now let me compile again just to check for the compile errors. We are good here. Let me submit it. Okay, so let's discuss the time complexity. The time complexity is going to be of n square because of this for loop, and another is this while loop. Okay, this can go till n of n. So yes, all the test cases are passed. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Okay, and also the space complexity is O of 1, as we are not using any extra space. So the C++ code also we can quickly check. It's almost the same. Okay, this almost the same. Okay, not much difference here. Okay, I'll attach the code in the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a happy, healthy, wealthy, and a great day. Thank you so much.